Compared with the landing of the Zhurong Mars rover in 2021, CNSA's Chang'e 5 lunar sampling and returning mission in December 2020 didn't draw as much attention from the English-speaking mainstream media and their followers. Although both have valuable scientific research tasks, compared with the distant Mars mission, the lunar mission has potentially more economic value in the short term, with profitable exploitation of lunar resources, future deep space exploration transfer station and the Lunar Research Station, etc. In the future, industries with a value far exceeding trillions might be created. Besides those general pictures, the value of the Chang'e 5 mission itself is far more than bringing back 1.7 kilograms of lunar soil for the first time in 44 years. The complexity of the mission was deliberately increased by CNSA. The historical world's first automatic rendezvous and docking of spacecrafts in lunar orbit is a forerunner for future crewed missions and the construction of lunar research stations. Today we will take a look at how on Earth CNSA succeeded in Chang'e 5, and what processes it went through during the mission. The name of the Chinese lunar exploration project is Chang'e. Chang'e is a fairy in ancient Chinese myths. The myth of Chang'e flying to the moon originated from the ancient people's worship of stars. It is also said that Chang'e created a precedent for monogamy. The Chang'e lunar exploration project was officially launched in 2004 and was divided into 3 stages: orbiting around the moon, soft landing on the lunar surface and returning lunar soil. In 2007, Chang'e 1 obtained China's first 3D full moon map and hard landed on Mare Fecunditatis area. In 2010, Chang'e 2 increased the image resolution to 7 meters and photographed the landing site for Chang'e 3 U2 rover mission. After completing lunar mission, Chang'e 2 flies to Earth-Sun L2 Lagrangian point, and then asteroid 4179 to Taurus for extra explorations. The full moon map data obtained by the Chang'e missions is made public, which further refutes some conspiracy theories about relics of aliens or prehistoric civilization on the lunar surface. The link for the full moon map is in the video description. In 2013, Chang'e 3 successfully landed on the near side of the moon and released the lunar rover, named U2 or Jade Rabbit, which was Fairy Chang'e's pet, making China the 3rd country to soft land on the moon after the former Soviet Union and the United States. In 2018, with the help of the Cheqiao relay satellite launched to the L2 Lagrange point, Chang'e 4 became the world's first lunar rover to softly land on the far side of the moon. It carried scientific instruments from China, Sweden, Saudi Arabia, Germany, etc. The payloads have obtained a large amount of environmental and geological scientific data, and verified the feasibility of the lunar planting with a closed ecosystem. Low-phenol cotton seeds germinated in the closed ecosystem and became the first sprouts of terrestrial plants on the moon, which survived for a total of 8 days 20 hours and 45 minutes. These achievements are just the beginning of CNSA's lunar ambitions. The latest mission of Chang'e 5 was not only sent to explore around the landing zone, but to bring back something on the moon. This was the first lunar sample retrieved by mankind in 44 years, and it was also the first time in human history to sample lunar soil with a geological age of less than 2 billion years. The entire journey of Chang'e 5 mainly includes 9 steps, and we are showing them as a progress bar here for your reference. They are rocket launch, Earth to moon transfer, soft landing on the moon, lunar soil sampling, ascender launch from lunar surface, automatic rendezvous and docking, in-orbit sample transfer, moon to Earth transfer, and soft landing on Earth. The mission complexity and risk of Chang'e 5 is an order of magnitude higher than that of Chang'e 1 to 4. Let's review how these steps are achieved. Chang'e 5 is designed to go to the moon first and later come back to Earth. So, this mission will not only bring various experimental instruments, but also the fuel and boosters needed for the return. This leads to the multi-stage design of Chang'e 5. With a weight of up to 8.2 tons, heavy rocket must be used. This rocket to launch Chang'e 5 is the Long March 5. The Long March 5 rocket is CNSA's most powerful rocket with 25 tons of low Earth orbit capability. It ranks among the top 3 in the world, after NASA's Delta IV and SpaceX's Falcon Heavy. Compared with the Long March 3 which launched Chang'e 1-4, this carrier rocket is significantly more capable of sending heavy probes into higher orbits. The very same rocket launched Tianwen-1 Mars rover to the Earth to Mars transfer orbit in the same year. At 4:30 a.m. November 24, 2020, the Long March 5 carrier rocket launched the Chang'e 5 probe into space at the Wenchang Space Launch Site in Hainan Province. Numerous aerospace enthusiasts watched the launch process near the launch site in Hainan. The sky over Wenchang was overcast, and a bright orange light spot could be seen passing through the clouds in the night sky. About 36 minutes and 42 seconds after the launch, the Chang'e 5 probe was sent into the Earth-Moon transfer orbit. The abandonment time of the fairing during the rocket launch was delayed to ensure the ground safety of the Philippines under the flight trajectory. As the solar panels of the probe finally unfolded, the launch mission was done successfully. After days of flight, Chang'e 5 reaches the Moon. It would slow down and be captured by lunar gravity, then it would land on the surface of Moon as planned. When Chang'e 5 is near the Moon, its speed has reached 10 times that of ordinary jet airliners. So if it doesn't slow down in time, its speed would be too high to be captured by lunar gravity. Then it would pass the Moon. But the braking cannot be too hard either. Otherwise, it may hit the Moon head-on. Compared with the braking of previous missions, the accuracy requirements are higher. After 2 times of braking, the probe enters near circular orbit. In the process of flying around the Moon, it will be divided into 2 parts. The orbiter-returner combination, staying at about 200 kilometers height, continuing to fly in orbit around the Moon. The lander-ascender complex gradually lowers down its height to 15 kilometers for landing preparation. After landing preparations, the lander-ascender combination continues to lower its altitude from 15 kilometers to a distance of 2 kilometers, and then 100 meters, 30 meters above surface. Finally goes to 2 meters. At this height, the lander-ascender combination would shut down the engine and do free fall. Here we have the videos from the control center during the soft landing process with on-site commands. Lander-orbiter separation. Great Wall reporting, separation finished. Repeat, separation finished. On the top we have the lander-ascender complex. The orbiter is at the bottom of the screen, on the right is the Moon. (7,500 Newton) engine starts. Controlled landing ongoing. The Chang'e 5 probe has entered a process of controlled lowering down with power. Right now, the lander-ascender complex is having a main deceleration process. The main purpose of this phase is to reduce the speed of the probe. The relative speed of the probe and lunar surface is reduced to 30 meters per second. Now the probe is flying with a sliding angle. Flying to the landing spot. The chosen landing area is named Oceanus Procellarum. The reason is because scientists think this is a relatively younger surface. At the same time, no other detectors have been to this area. So we want to enrich the knowledge of the surface of our Moon. Quick adjusting mode. It has started now. It's pretty fast. Now it's approaching mode, and the attitude was properly adjusted. In fact, this attitude adjustment looks very good. He just moved from an angled flying to almost vertical direction. This flying still has a little bit angle like 10 degrees. It is in the approaching phase now. It's getting closer and closer to the lunar surface. This is from 1.5 kilometers to 100 meters. In this process, it uses the optical sensor, automatically checks the terrain, and finds the safe landing spot. Shift to hovering mode. Now the probe is hovering at around 100 meters and avoids obstacles. When hovering, it uses a laser sensor to look at more specific terrain with ups and downs, so that it can more accurately find the spot where it can land. Now it finds the spot it wants. Now it's in obstacle avoidance phase. I see that the above shows a slow descending phase. Is this the last action before landing? Yes, the last 30 meters. Shift to slowly descending mode. About 2 meters. The engine will shut down. Great. Is it done? Yes, it landed successfully. Engine shuts down and we see Chang'e 5 has landed steadily at the spot it selected. It landed successfully. It will start surface sampling and drilling tasks. Attention all systems. This is Beijing. The lander-ascender complex has landed. Now we are seeing the accelerated landing video from Data Release and Information Service System of China Lunar Exploration Program. And also the landing spot panorama. The landing spot is near the Lump Mountains in the northern Oceanus Procellarum on the near side of the Moon. It is about 1,000 kilometers west of Sinus Iridum, which was the landing spot of Chang'e 3. This is the first time that a human-made probe sets foot in this area on the Moon. Why did we choose to land here? According to scientists' speculation, there is evidence of multiple volcanic eruptions in this area. It even includes some youngest lunar mare basalt. The lunar soil in this area is younger than other places, which is yet unexplored for lunar geological scientific research. At 2311 December 1st, after the lander-ascender complex lands on the Moon, it first drills through the lunar ground, taking the samples by drilling down below. In 17 hours after that, it starts to use sampling devices on the robotic arm, and starts the surface sampling. It only took 12 times of sampling to fill the sample container. Sampling tasks were completed ahead of time. The process went faster than expected. After sampling, the lunar soils are encapsulated in primary sealing device. The robotic arm then transfers it to the ascender. The lunar terrain around the landing spot would be reconstructed here on Earth with the help of AR. Before sampling, ground verification and experiments would be done first by a twin probe of Chang'e 5 on Earth. Now we see the video of the drilling from Moon. This is the first sample collecting method. And here we have the ground station video of sampling by the robotic arm from the reconstructed site on Earth. Engineers test the whole process before sending the orders to Chang'e 5 on the Moon. Now we are seeing the video clips of the surface sampling by Chang'e 5. The robotic arm transfers collected soil to the container and repeats the process for 12 times. The sample container was then sealed and transferred to the ascender after sampling. This is the panorama of the landing site after sampling. Traces of the sampling are left by the robotic arm. A national flag made of fade-resistant material was raised on the ground of the Moon. After sampling lunar soil and sealing it in the container, the ascender is ready to leave the lunar surface. During the ascending phase from lunar surface, the ascender uses the lander as its launch platform. Ascender would then fly away from lunar surface. And after the lander takes its last pictures for the ascender, it will stay on the Moon forever. Now we have lunar surface ascending phase video from the control center. Attention all systems, this is Beijing, 10 minutes to go. Mechanical separation of lander and ascender. Electric separation of lander and ascender. Great Wall Report, 3000 Newton engine starts, ascender lifts off. Engine starts. Ascender lifts off. Lifting off time, 23, 10, 21, 0 millisecond. Great Wall Report, shift to ascending attitude adjustment mode. Shift to orbit insertion mode. Great Wall Report, 3000 Newton engine off, status normal. Engine off, ascender status normal. Great Wall Report, ascender solar panels deployed normally. Attention all systems, this is Beijing, ascender solar panels deployed normally. In CNSA's past rendezvous and docking missions, the two docked spacecrafts were about the same size. And this time the automatic lunar orbit rendezvous and docking is different. The ascender is much smaller than the orbiter-returner combination. The ascender is only about 500 kilograms before docking. And the orbiter-returner complex is about 2,000 kilograms. For such a large weight gap, if we still use the previous simple collision docking, what will happen? Let's imagine what happens when an adult bumps into a child while running, then you know it. So in order to prevent the ascender from being bumped away, on the one hand, orbiter-returner complex should reduce the relative speed before docking. And it has to capture the ascender immediately when docking. So a brand new docking structure was designed by researchers. Let's take a look at what the docking structure looks like. There are 3 passive bars on the ascender. These 3 bars do not have actions by themselves when docking. They just function as grips for orbiter-returner complex. What kind of equipment is used to catch them? Look again. Those are the 3 gripping docking structures. Before docking, those are like open hands. Once touching the passive bars of ascender, they will quickly close. Hold the passive bars and forcefully close the gap to achieve docking. The orbit during docking is far away from the Earth. Accuracy of alignment needs to be guaranteed. The relative position error of the docking cannot exceed 5 centimeters. If the alignment is not accurate enough, and they do not capture ascender, it would take much more effort to give it a second try in that case. Here we see the rendezvous and docking video. Ascender is in the middle of the screen, the Earth is visible on the left. The view camera is on the orbiter. The gripping structures on the orbiter automatically close the hands and catch the ascender. Docking is done now. Now the in-orbit sample transfer starts. On the top we have the ascender. The returner module together with the orbiter is at the bottom of the screen. In the middle we have the sample transfer channel. The ratchet structure moves the sealed sample container from the ascender to the returner. Now the ascender is separated from returner and is taking away the docking structure with it to reduce returning weight, and will be controlled to crash on the moon to avoid leaving space debris in the lunar orbit. Ascender orbit control mode starts. Great Wall Report, engine starts. Orbit control starts. Orbiter attitude adjustment mode starts. Engine off. Orbit control finished. Great Wall Report, ascender telemetry signal terminated. Controlled crash finished, ascender telemetry signal disappears. First insertion of Moon-Earth transfer now begins. Engine starts. Orbit control starts. Then we have the second insertion of Moon-Earth transfer. Engine starts. Orbit control starts. Engine off. Orbit control finished. Attention all systems. This is Beijing. Second orbit control for Chang'e 5 Moon-Earth transfer ended normally. Finally, we have the lunar soil returning to the Earth. Before entering the atmosphere, we have the orbit returner separation. Returner capsule recovery team departs. We see the infrared video since the landing time is at night. After releasing the returner, the orbiter conducted evasion maneuver. It will fly to the Lagrangian L1 point of the Sun-Earth system for further exploration. As for the entry process, due to the second cosmic speed, the returner cannot go back in usual ways like Shenzhou capsules due to extreme heat. It uses a two-phase entry method with returner bounced back to space by atmosphere and entering the atmosphere a second time with a lower speed. Now we have the returner re-entry infrared video from ground tracking station. Returner main parachute is deployed. Chang'e 5 returner touchdown on Earth with the precious lunar soil in Inner Mongolia. And we have the first mammal passing by the capsule, which is surprisingly not a human being. Returner capsule is waiting for recovery. Now recovery team arrives. At this moment, the whole Chang'e 5 mission is completed. The young lunar soil is finally there for scientists to study. We have been watching Chang'e for 23 days, and today we finally see the returner capsule carrying invaluable lunar soil landed on Earth. Just around 10 days ago, Chang'e 5 independently displayed the national flag on the moon for the first time. Today, we see on the Earth again. 5-star red flag fluttering in the wind. Next to the flag, we have Chang'e 5, which just made history. Indeed, tonight is the time every Chinese can be proud of. This is the story of Chang'e 5 mission. Institutes can apply for usage of lunar soils for research purposes at the Data Release and Information Service System. The data and details of the 1.7 kilogram lunar soil are published in Lunar Sample Information Database. The link is in the description. With its success, China has completed 3-step plan of orbiting the moon, soft landing rovers on moon, and sample returning right on time. With the lunar exploration's huge scientific and economic value, CNSA is not making the lunar program merely a publicity showcase. In the near future, more lunar probes will be sent to the moon to look for potential water resources. Chang'e 6 and Chang'e 7 probes will explore areas around the South Pole for potential spots to construct lunar stations. A mini-flying probe launched with Chang'e 7 will be able to fly into permanently shadowed craters to detect signatures of exploitable ice. CNSA together with Roscosmos also announced the initiative to build the International Lunar Research Station, or ILRS. For CNSA's future lunar explorations and details about ILRS, please subscribe and tab the bell, and we'll make an introduction video of how ILRS is going to be constructed and what we should expect from the exciting project. Stay tuned and see you next time.